Welcome back. In this video, we're going to talk about solving different types of quadratic equations, and we're going to use some further factoring methods. So all of these will be factorable. Keep in mind that equations that you can factor, you can also always solve using the quadratic formula. However, there are certain equations which are not factorable. So again, everything that we're going to see in this video will be factorable, and we'll talk about the different strategies. So the different strategies that we will look at would be using guess and check to factor, the AC method to factor, the bottoms up method to factor, and we looked at all three of those in the video, which was right before this. We'll also have some examples where we need to factor a GCF first, or we can factor by grouping. And there was some factoring by grouping also in that previous video because it was inside the AC method. So quadratic equations are equations formatted like this, and this is our standard form. Now, standard form is written in descending order, whereas the powers go down. So we have a squared or a quadratic term plus a bx, that's my linear term, plus c, my constant, equal to 0. And so organization is very important when we are solving quadratic equations. So let's jump into and look at some examples. This first equation that we're given to solve is 18x squared equals negative 9x. Now this does not look like our traditional standard form, but we recognize that this is a quadratic equation because we see x squared and then we have negative 9x over here being my linear term. So the first step is I'm going to put this in descending order. So that would be 18x squared plus 9x equals 0. Now, in this situation, we have our quadratic and our linear term, but we are missing our constant term. Remember, my standard form is ax squared plus bx plus c is equal to 0. So there's no constant term here. One thing we should be able to recognize is that we can factor out a GCF. And if I look at factoring each of these terms, I will notice that they both have a 9x inside. This first one is 2x times 9x. And then the other term we could write as 1 times 9x equals 0. So here I'll factor out my GCF of 9x, and that leaves me with 2x plus 1 equals 0. The 2x and the plus 1 are coming from those coefficients that I factored out. So now that I have this in factored form equal to 0, I'm going to use my zero product principle, and I'll set each factor equal to 0. Here I have 9x equals 0 and 2x plus 1 equals 0. Solving each of these factors, if I divide by 9 on both sides, 0 divided by 9 is still 0. And then for the other one, I will subtract 1 and divide by 2, and I have x equals negative 1/2, because we subtract 1 and then divide by 2. So you can see I have two unique solutions to the originally provided quadratic equation. For our second example, we're going to look at the quadratic equation 10x squared plus 6 equals 16x. One thing you may notice here is, again, this is not written in standard form. We have quadratic, constant, equal to a linear term. And again, we always want that in descending order equal to 0. So I will subtract 16x from both sides of the equation, and that gives me 10x squared minus 16x plus 6, and then of course 16x minus 16x is equal to 0. Now we have this in descending order. One thing you may notice looking at all of these terms is that they're all even numbers, which means they're divisible by 2. And therefore they have a GCF, in this case, of 2. I'm going to factor that GCF out first. So that gives me 2 times 5x squared minus 8x plus 3 is equal to 0. Now, I could still have solved this problem without factoring out that GCF of 2. However, it's going to end up reducing my problem. Since I'm dealing with an equation that's multiplied by 2 on the left, well, I can divide by 2 on both sides. That cancels my 2 in the front. Now I have 5x squared minus 8x plus 3 equals 0 divided by 2 is 0. I do think it's important to note here, if we had factored out a GCF of x, we cannot divide on both sides by x. And keep in mind, x is a variable, which means it represents a number for which we do not know the value. And if we don't know the value, that means it could be 0. And we are not allowed to divide by 0. Therefore, if this GCF had been a variable of x, this step would have been illegal. But because it was 2 multiplied by 2, I'll divide by 2 on both sides. Now I've reduced my equation. At this point, we can factor using either the AC method or guess and check or bottoms up. I'm going to look at bottoms up. So since my leading coefficient is not 1, I'm going to take that 5 and multiply it through. Now I have x squared minus 8x plus a positive 15 equals 0. At this point, I'm looking at factors of positive 15 that would add to give me negative 8. And I would either have positive 3 and positive 5 or negative 3 times negative 5. We also have 15 and 1, negative 15 and negative 1, but hopefully you see the negative 3 and the negative 5. That's what's going to sum to give me that linear term, negative 8. At this point, I can factor. That will be x minus 3 and x minus 5. Now, the tricky part with bottoms up is we have to remember this next step. Recall, I multiplied through by 5. So that was kind of an illegal or math magic sort of move. And in order to fix that multiplication, at this step, I now need to divide both of these by that 5 value. If you forget that, you would get this wrong. If you'd forgotten that step, you would likely assume here that you would get x equals 3 or 5, which would be incorrect. So remembering to divide by that number we multiplied through, and that was times 5, so I'll divide each of these terms by 5, which gives me my correct factored form of x minus 3/5 and x minus 1. So now I have two factors multiplied equal to 0. That's going to give me that x is positive 3/5 as well as x equals positive 1. Setting each of those factors equal to 0, I will get these two values. Remember, when you get your two solutions, you should always check them in the original equation to make sure that they give you a true statement. So coming back up here, so if we were checking both of those values, x equals 3/5 and x equals 1, I would plug 3/5 in to the left and right and make sure I get the same value on each side, just as I would plug in 1. And I'm not going to deal with the fraction here, and because that would just be a little bit messier, but I'll plug 1 in for both of my x's, and you'll see I get 16 equals 16. So plugging in 3/5, you'd get 9 over 25, and then we've got to divide and reduce. But both of those are solutions for this quadratic equation. I'm going to do one third example in here. For this third example, we're asked to solve 6y cubed minus 10y squared minus 4y is equal to 0. Now you may be looking at this and saying, well, Ms. Stein, this is a cubic equation and we're learning how to factor and solve quadratic equations. Well, if you look at this, you'll notice that all of my terms have a y value. That means I can factor out a y as a GCF. You may also notice that 6, 10, and 4 are all multiples of 2. So the GCF that I'm going to factor out first is actually 2y. I'm going to factor out the value 2y. That gives me 2y times 3y squared minus 5y minus 2 equals 0. At this point, I have essentially factored the equation. I have two factors, and if I have two factors multiplied together to equal 0, then either one or the other factor must equal 0. So you can see I've written my first factor, 2y equals 0, and then my second factor, 3y squared minus 5y minus 2 is equal to 0. Now, I did have the option to divide on both sides by 2, which would have just given us y equals 0. But remember, we don't want to divide on both sides of the equation by a variable to cancel that, because we don't know what that variable is equal to, and it could be equal to 0, which would mean we would be doing some illegal math. But since I have 2y equal to 0, I will divide both sides by 2, which gives me y equals 0 as one of my solutions. So this other factor, now we are solving a quadratic equation equal to 0. At this point, I'm going to use the bottoms-up method to factor since my leading coefficient is not positive 1. That means I'm going to come over here and multiply by 3. Now I have y squared minus 5y, and that becomes minus 6. Most students find that once that leading coefficient is 1, that this problem becomes much easier to solve. So looking at two factors of negative 6, and we're going to be looking for those two factors to add to equal negative 5. Listing my factors of negative 6, we could have negative 6 and positive 1, or positive 6 and negative 1. Negative 2 and positive 3, or positive 2 and negative 3. Here we have to choose the pair of numbers which is going to sum to equal negative 5. Now be careful, because most of us are going to think, hey, 2 plus 3 equals 5, but you have to pay attention to the fact these are opposite signs. We're actually going to choose negative 6 and negative 1. That means I can factor this as y minus 6, y plus 1. So the last step of the bottoms-up method, because I multiplied by 3, now I need to divide each of these terms by 3. So I actually have y minus 2 and y plus 1/3 as my two factors, which gives me y equals positive 2 and y equals negative 1/3. So looking at this, how many solutions did we find? And you all should notice that we have 3 values that are possible for y. I'm going to come up here and point out the type of equation, or the power on the equation we were dealing with. It was y cubed. Whenever you're dealing with something that is cubic, you are going to find 3 solutions. So it's no coincidence that we got 3 solutions for this cubic equation. Now, the other thing to keep in mind is you can always check these solutions. And when I say check, that would mean that we would need to take each of these 3 solutions, plug them in, and make sure that they give us a true statement. And you'll notice by plugging 0 in for y, positive 2 in for y, and subsequently negative 1/3 in for y, they all simplify down to 0 and check. So I hope that gives you a little bit more of an understanding about some different factoring strategies. Now, every single one of these problems could have been solved using the quadratic formula. We're going to get to that in a minute or in the following video, but I just think it's very important for us to try to factor, especially if we can. And generally, factoring is a little bit less work than actually using our quadratic formula. As always, please feel free to reach out if you have any questions or concerns because I am here to help.